divided this into 2 units. And since we divided it into 2, the tests have gone a lot better, So it's a shorter unit. There's not many assignments. There's only about 4. It's not going to take us that long to get through it. We'll start a little bit today and next week, and then we'll pick it up when we get back from break. And when we get back from break, we will review what we talked about ahead of time. But just to give you an idea, we want to be able to take something like the square root of 20, and we want to be able to reduce that. That's our goal today, is to be able to simplify radicals. Does anybody know a perfect square that divides into 20? 4. 4 is a perfect square. How many times does it go into 20? 5. So you can write that as a square root of 4 times the square root of 5. What is the square root of 4? 2. So this becomes 2 roots of 5. So that's our goal for today, is to be able to simplify those radicals. Okay?
What? You didn't like that?
Yeah. So some of you guys have we'll show you. We'll take some time. Some of you guys have learned factor trees. That's fine. You can use factor tree. I'm going to tell you right now. It just really takes a long time as you progress further in mathematics. So as you take a class in college, I don't see your teachers using factor trees at all. Okay, I don't see them using it at all. They're going to use this. Okay, so you want to be prepared a little bit for that. First, we need to focus on what the perfect squares are. Okay, you're going to get the list of perfect squares and cubes and fourths on the test, but let's list them off. 1 squared is obviously 1, and 2 squared is 4. 3 squared,
9.
4 squared,
16.
5 squared,
25.
6 squared,
36.
7 squared,
49.
8 squared,
64.
9 squared,
81.
10 squared.
100.
How about 11 squared?
121.
Ooh, 121.
144.
144.
169.
169.
196.
196.
225.
225.
256.
256. How about 17?
I don't have that one memorized.
Good question.
I thought you even had it memorized.
Yeah, the
I
fact that
was
you
a
had
weirdo in
13
sixth
through
grade.
16.
Good for you.
You remember that
This
in
was
6th
sixth grade
grade?
back?
So there you have it, okay?
6th grade.
Those are your perfect
so.
squares. A nice list, a list that you're going to use quite often in this unit. We'll move on to the perfect cubes. The perfect cubes, let's start to list those off, okay? So we have 1 cubed is 1. What is 2 cubed?
8.
It is 8. 3 cubed is 27. What is 4 times 4 times 4 is 64.
125.
125.
216.
216. Look at Hannah go.
343.
343.
512.
And 512.
You would memorize or
No.
did you do it? That's awesome.
I did 6, 7, and 8 on the calculator.
Perfect force? What is that?
Perfect force. That means if you multiply it by itself 4 times. So 1 times 1 times 1 times 1 is 1. 2 times 2 is 4, times 2 is 8, times 2 more is... So 16 is a perfect fourth. 3 times 3 is 9, times 3 more is 27, and then times 3 more is 81. 4 times 4 is 16, times 4 more is 64, times 4 more is 256, and 5 times 5 times 5 times 5, 625. So our goal is to take those perfect squares, thirds, and fourths, and be able to use them to simplify radical expressions today. So you see the first one on the board, it says the square root of 48. Who can think of a perfect square that divides evenly into 48? 16 does go in. 16 goes in how many times? It goes in 3 times. So here's how I show you, okay? I just find the number that divides in evenly. I have the square root of 16. I put the perfect square first. And then I put the other number second. Okay? Because 16 times 3 is 48. As you multiply those, you should always come up with that up front. And now we take the square root of the first one. What's the square root of 16? 4. So this just becomes 4 times the square root of 3. I'm done.
You don't understand that I do.
Hi.
And you do.
What is the perfect square that divides evenly into 28? 4. So I choose, notice some people maybe thought 2 and 14. Neither one of those are perfect squares. So I'm going to choose 4 and 7. Square root of 4 times square root of 7. I always write the one with the perfect square first. So I'm going to simplify this. What is the square root of 4?
2.
So this becomes 2 roots of 7. What's a perfect square that divides into 125 evenly?
25 and 5.
So I have the square root of 25 times the square root of 5. What is the square root of 25? So this becomes 5 roots of 5. So on your assignment, you're going to practice simplifying square roots, but we're also going to have cube roots. This is very important. People fail to do this on the test. You're not going to get the problem right if you don't do this. Notice how it says cube root. So I draw my attention not to the perfect squares, but to the perfect cubes. Look at this grouping right here. What's a perfect cube that divides? Guys, stop talking when I'm talking. What is the perfect cube that divides evenly into 16? It is 8. That's the one I choose. So I'm going to bring this up, and I have the cube root of 8 times the cube root of 2. Okay? That's how I set it up. And then I ask myself, what is the cube root of 8? 2. So this becomes 2, and you attach onto it cube root of 2. What's different about the next one? It's the fourth root. So therefore, I draw my attention to the perfect fourths right here. Which one of these divides evenly into 162? 81 goes in how many times? Twice. So I write the fourth root of 81 times the fourth root of 2. Notice that whenever I write it, I have to have 2 numbers that multiply to that, and one of them in this situation has to be a perfect fourth. What do you multiply by itself 4 times to get 81? 3 fourth roots of 2. A lot of times on the test, people forget to write that fourth root index number. That's a half a point off if you forget to do that. Okay. The next one, 81, it says cubed root. So I go back here and I look for cube root. These are my cubes. Which one of these divides evenly into 81? 27. If you don't see that, that's okay. Try it on your calculator. 81 divided by 64. 81 divided by 27. See which one divides evenly. It turns out it is 27. How many times does it go in? So I have the cube root of 27 times the cube root of 3. Okay? You always simplify the first one. What is the cube root of 27?
3.
So I get 3 cube roots of 3. Just flip it over. We want to do these 6 and then we're done for the day.
You're crazy. Already? You're crazy.
We want to look at the fourth root of 625. What do you multiply together 4 times to get 625? 5. And then notice you have a variable, x to the 20th. What do you multiply by itself 4 times to get x to the 20th?
5.
X to the 5th. So Christian says x to the 5th times x to the 5th times x to the 5th times x to the 5th. Notice when you multiply that 4 times, you add the exponents and you get x to the 20. So this reduces to 5x to the 5th power. The next one, I forgot to put the square root or the cube root all the way over it. My mistake. What is the cube root of 27? 3. What do you multiply 3 times to get y cubed?
Why?
Y. What do you multiply 3 times to get z to the 6th? Z to the 2nd. The third one, what do you multiply 3 times to get 216? What do you multiply 3 times to get x to the 15th? X to the 5th. Notice how that was a perfect fourth. That was a perfect cube. That was a perfect cube. Uh-oh, now we get to a situation, 32 is not a perfect square. So these last 3 are where you really want to lean in. This is where people get points off on the test. I have the square root of something times the square root of something. What is the perfect square that divides evenly into 32? So I put 16 here. What do I put on the other side? 2. X cubed is not a perfect square, is it? So I have to change it. I start to reduce the exponent. Instead of x cubed, I'm going to try x squared. Is x squared a perfect square?
Yeah.
So I can put an x squared here, but then what do I have to put over there? An x. Y squared, is that a perfect square?
Yeah.
Yep, so anything that's a perfect square goes underneath here. But remember, we have to put the stuff over there to make sure it multiplies to what you have up here, okay? So notice 16 times 2 is 32, x squared times x is x cubed, and y squared is right there. So we just take the square root of this piece, square root of 16, x squared, y squared, 4xy, and then we attach the root of 2x. So a square root is an operator, kind of like addition, subtraction, multiplication, and division. Square root means we find what to multiply by itself. So it goes away once you perform that operation. Is 49 a perfect square?
Yes.
So it could go underneath there. Is x to the 5th a perfect square? So what do?
Bring it down to 4x.
Yeah, reduce it to x to the 4th. So you have to put an x over here. Is y to the 7th the perfect square?
No.
So reduce it to y to the,
6.
and then you put a y over there. See if you can finish that off. And I get 7x squared y cubed times the root of xy. Okay? Last one for the day. What is the perfect square that divides evenly into 50? I put 25 and I put 2. Is x to the 4th the perfect square?
Yeah.
So I put the x to the 4th here. Is y cubed a perfect square? It is not. So I reduce that to y squared, and the y goes underneath there. There we have 25x to the 4th y squared. You take the square root of that, and you get 5x squared y, and then you just leave root of 2y. Okay? So finding square roots, very important. This is good practice for what you're going to see later on. As you look at your assignment,
I thought this stuff.
the first page of your assignment says simplifying, adding, and subtracting. Today we are not adding and subtracting. You will only go to problem 21, which sits on the back side, okay? After that, they're adding and subtracting. We want to talk about adding and subtracting next week, okay? One last announcement. A lot of people have asked